This is Spare Time Repair, and this is a Marantz CD-150. This tank-like unit dates from 1985, and as soon as I saw it for sale, I knew I had to buy it. The eBay listing described this model as rare, and given the paucity of information about it online, I'm willing to believe that. The fault is that it will accept a disc, but won't spin it up, something that's apparent even with the lid on thanks to this illuminated acrylic window in the tray. There's also a bit of damage to the aluminium tray fascia, which I can hopefully improve. I've already seen footage of the inside of this player, so I know what to expect, but that's exactly why I wanted to buy it. This is a full width unit, but because it's so tall, it kind of feels like it's narrower. It's a bit of an optical illusion. Top cover's in very good condition though. Well, we've got this very nice metal clamp, which looks very sturdy, and it appears to be all gear driven, so it won't be a slack belt that's causing the issue. Well, I've never seen a leaf switch like this mounted on the top of the clamp, so let's switch it on and see the tray in action. Since Marantz were owned by Philips at the time, I'm a bit surprised that it doesn't have a Philips swing arm pickup. This green light illuminating the tray is incandescent, and in general it looks really clean in here. The DAC is a Burr Brown PCM 53JP-V. Besides that, we have Yamaha, Sony and Hitachi chips. So one reason why the disc won't spin up could be the turntable motor, or it could be that the laser's not finding focus, because if it can't do that, it won't bother spinning up the disc. Either way, I need to remove this tray in order to have a better look. There's no free service manual available for this one, so I'm on my own. Actually, I'm just feeling underneath here at the disc turntable, and it's really stiff. Feels like the motor's just got seized up. So with any luck, that's the only issue. Now, how do I get this tray out? Well, the only thing I can see holding the tray in is this gear at the back. So first I need to remove the clamp. And to do that, I need to remove a little circlip on the right-hand side here. Came off quite nicely. So you need to unhook this spring as well. I'm scratching this up here. Going to unscrew this leaf switch, give me a bit more freedom. Need to snip this cable tie as well. There we go. Clamps don't get much more solid than that. And there's the troublesome spring. Well, you can see that turntable isn't moving. It will if I press it a bit harder. But I think the reason why is it slipped down the shaft a bit and now it's pressing against the pickup. So if I gently lift it. There we go. I imagine that's because the metal clamp presses down quite firmly, and over the years that's just pushed it down the shaft. It's a fairly convoluted gearing system to move the laser sled. This is the motor shaft, and that's turning these two gears, which is operating this rack gear, which will very slowly move the laser. It seems a little bit flimsy and fragile. This doesn't look square to me. It still appears to be working all right. And this pickup is enormous. I'm not sure who that's made by. That appears to be the part number for it. I thought removing this gear would release the tray, but there's actually teeth underneath here going under the tray, so that can't be right. But there are screws on these retainer clips here, so maybe that's how you do it. Well, maybe I only needed to do those end two because it's now released it from the gear. This clip doesn't want to come off. There's a little tab underneath to release it. Maybe that's how I should have done it in the first place. There's a little tab here that needed bending. Well, I'm going to put those clips back. This is a very robust transport. We've got 3 of these leaf switches, so it's going to be worth giving those a clean. Let's see how bad they are first. Well, if you press it hard, it's pretty good. Same with that one. Same with that one. Never hurts to clean them anyway. You always get something off them. Well, it looks like I can remove the whole transport with these 4 screws. We should release it from these rails at the back. If I undo these connectors, it comes free. Well, there are no clues underneath about who made the pickup, but there's another nylon wheel here where the sled is travelling along. It looks like the pickup is secured with another circlip. And there's a spring on this plate. Quite unusual. Got the adjustment pots along the back here. It looks like I can remove the sled rail by removing these clips. Let's remove this screw first. Well, it should let me slide the rail out, and then the whole pickup drops. Well, that doesn't benefit me, so I'm just going to rest it gently on there and clean off this old grease. Probably nothing wrong with this grease, but it's nice to put some new stuff on. Going to put a bit of oil on the motor shaft, though that one's feeling fine. And now I've freed this one up, I think it's also fine, but might as well do it while we're here. There's one more motor for the tray. I can't really get to the top bearing, so I'll put some in the bottom instead. Slide that back in. Feels pretty smooth. And I had a look at the lens through a magnifier, and it's pretty clean. I'll do it anyway, of course. Refit these gears. And I just want to add some grease where this wheel slides along here because that's all worn away. And this hook at the bottom here is for a transport lock, which is operated via this screw here, which goes through the bottom of the case. Just moves this lever out to hook over it. Nice brass standoff for the PCB. It's got very good build quality. So let's get it back in. Reconnect our cables. Before I refit the tray, I want to see if there's anything I can do with this. You can see from the top it's taken a blow and it's bent it out slightly. Should be able to release that with these catches. Well, it's not popping off as easily as I thought it would. I think there might be a T-zip behind here as well. Yeah, double-sided tape, and that's also what's holding on the aluminium panel. I need to be very careful with this because I don't want to bend it anymore. Just going to drip some alcohol inside. Let that sit for a minute, see if it dissolves the adhesive at all. Well, strong adhesive, I'll give them that. There we go. Well, it's never going to look as good as new, but if I can just remove that kink, it should improve the appearance. Well, I'm wondering if I protect the top surface with a piece of card, whether I can use these grips to just get rid of this wrinkle. I just gently tighten them up. Probably easier if I cover the jaws with tape. It's so hard to make it look good once it's been damaged. I then got it as straight as I could by clamping it to the edge of the desk using this old transformer bracket. Well, I think it's certainly less obvious now. Well, the front panel is actually pretty clean, so I don't think I need to wash it, but I am going to remove it anyway just to have a look. You've just got a screw in each side and 3 in the bottom. And there's also confirmation of that transport lock. So we're tethered by this power button and this green light that's over the tray. And that green light is just a regular lamp with shrouding over it. Well, these ribbon cables seem to be friction fitted and they don't want to release very easily. But I don't actually need to. Just one screw in the PCB. Those 7-segment displays are all individual. See what kind of resistance we've got on these buttons. They all seem pretty good. Certainly not worth taking them all apart and servicing them. And it's an aluminium front plate with a plastic insert. There's a bit of wear on the paintwork around these buttons, but I think if you tried to touch that up, it would probably look worse than just leaving it. In fact, this outer piece is aluminium. This insert in the middle is plastic. And then there's another aluminium insert in that with all the buttons on. And this silver tape is no doubt for earth continuity. So I'm just going to refit all of that. Even the power button is pretty clean. And I think I'm going to use contact adhesive to restick this fascia. I'm going to leave this adhesive on the end of the tray because that won't do any harm. Well, that glue is now dry. And that's not going anywhere. You can snap it back onto the front. And it should now slide back in. Now to refit the clamp, and the reason this spring was so hard to remove is because it was going through the hook this way. If it were this way, it would have been easier. Trouble is, that's not the way it naturally wants to go. I don't think I'm going to be able to fit it if I feed it through here first. It really needs to go through here. Well, maybe if I slide the tray out again so it drops lower. Now I can refit the circlip and this angled leaf switch. So despite all that servicing, all I've really done to repair it is raise that turntable up by maybe 1 millimeter. So was that really all that was wrong with it? It's one of the slowest tray openings I've ever seen, but it must be correct because it's geared. And for 1985, let's have some tears for fears. Well, that's interesting. The tray isn't closing now, so maybe that limit switch is in the wrong place. If I open it, what happens? Yeah. but we still have no disk spin. And it is free now. Well, this is worrying. Well, I may have raised the turntable too high so that the laser can't get focus. But I should really check that we have a laser output. So let's see, I may have to close this limit switch when the tray closes. Yeah, good output. Maybe if I push this down a little bit. I think that's about as low as it can reasonably go. Well, will it be any different with that adjusted turntable? No. I can hear a motor noise, I'm not sure what it is. I can try it with a different disc in case it just dislikes Tears for Fears. Well, I've just determined that that motor I can hear is this motor for the laser sled. So if I do again, you can see that moving. So the sled is obviously moving into the position to read the table of contents, failing to do so, and then moving back to the home position. But is it just out of adjustment? Or have I done something wrong? At this point I tried various combinations of focus gain and focus offset adjustments, but it didn't make any difference, so I returned everything to its original position. Well, I think I'm going to take out the PCB and check those capacitors. Got this little board mounted on the side here with an adjustment pot, but I'm not sure what that's for. Well, it'd be nice to release these ribbon cables, but I don't think I can. But I should still be able to check all these capacitors. The capacitors are all fine, and they're all the Nichicon brand, so that's no surprise really. But I'm now wondering whether I missed something on the transport. Did I put everything back together properly? Spindle motor is working, I've just flagged it with a piece of tape. And if I apply voltage directly, so no issue there. I don't think I missed anything. I mean, I did forget to re-grease the sled rail, but I don't think that would have been causing the problem. So it's looking more like a problem with the laser. Maybe it's not strong enough. So I'm going to put the transport back in the unit and see if I can adjust it from there. Well, I'm quite sure that's made no difference at all, but let's try it. Well, there is a service manual, but I'd have to pay nearly $20 to download it. I think that's what I'm going to have to do. Well, the disc turntable motor is fed by these two wires here, the red and the black, that go into this socket here. And it's possible, albeit unlikely, that there's a bad transistor that's stopping the motor spinning up. So I just need to figure out which components are relevant to these pins here and check those over so that I can rule them out. Well, in the end I purchased the service manual. It was $17, but I thought it was worth a shot. And I have to say it's probably the most comprehensive service manual I've ever seen. And if nothing else, I learned that you can remove the bottom cover. So everything's just held together on these racks, and I now have access to the underside without having to remove the PCB. But I'm still not much further forward in my diagnosis. And you should never do it, but I did try adjusting the laser potentiometer just to see whether it would provoke some sort of disc spin, but it didn't. I tried it in both directions and it made no difference at all. So I put it back exactly where it was, and I measured the resistance across that variable resistor before adjusting it. And it seems to be this chip here that's responsible for the initial disc spin operation. And the manual helpfully provides all the voltages that should be present on those pins. So I'm definitely going to check those. I just removed the shroud from the pickup to check the focus and tracking coils were working okay. And they are. They're both giving me about 4 ohms of resistance, and everything seems to move freely as well. According to the service manual, it's a TAOHS-BR pickup. I couldn't find this specific one online, but I did find other TAOHS pickups, but I don't know who the manufacturer was. But anyway, I can't find any problems in here. I partially disconnected this PCB from underneath the transport, but I can't find any issues on here either. Well, I've been checking voltages on these chips, and the main chip of interest is this one, which is the servo controller chip. And I wrote the pin numbers in pencil just so it was easier to navigate. And 3 of the values are off. Pin 9 should be 4.6 volts, but I'm getting 0. Pin 15 should be 0 volts and I'm getting 3 volts. And pin 24 should be 0 volts and I'm getting 5 volts. Now, according to the service manual, that last one, pin 24, is responsible for the focus error offset. So the fact that we're getting voltage there when we shouldn't be does suggest there's something wrong with the focus error circuit. So turning it over, and we are still powered on. This is pin 21, so this is pin 24. So if I trace where that 5 volts is coming from, maybe that will lead me to the problem. Well, this is interesting because here's pin 24, 4.9 volts. It goes to here. This is a jumper wire, so it goes to here. And then it goes up to here. And this is a resistor. And on the other side of the resistor, it drops to 1 volt. To me, logically, that says the voltage is coming from the chip. So I don't know whether that points to a short circuit within the chip or that the service manual is wrong. Just to prove the point to myself, I've disconnected one end of this jumper wire, so now there's nothing going into this pin 24, but we still have 5 volts. So that proves it's coming from within the chip, and according to the service manual, it should be 0. And I think that proves, unless the service manual is wrong, that there's an internal short in this chip. Well, service manuals are occasionally incorrect, but it says it both here on the schematic. You can probably barely read it, but it does say 0 volts in that box that I've highlighted. And elsewhere in the manual we've got this IC voltage chart. And again it says pin 24 should be 0 volts. And given that pin 24 is related to the focusing, I'm pretty confident that's our problem. Well, I guess we'll find out because I've just ordered a replacement chip from eBay. And it's coming from Texas. It'll take about a week. And I hate waiting for parts, but sometimes you have no choice. The new chip has arrived, but before I fit it, I'm going to remove the old one and then compare them both to see if they behave differently out of circuit. Out it comes. That was definitely not the most efficient way of removing a chip. These numbers at the bottom are just a date code or a batch code, and the original says 81, so presumably that's the year. Given that the player was made in 85, it had been hanging around for a bit. The replacement one is 84. Well, I've done a quick comparison, and pin 24 on the original chip isn't shorted to any of the other pins, but that doesn't necessarily mean there's not a problem internally. But the only way to find out is to pop in the new one. Of course, I need to put it in upside down. That's how the other one was. Those joints all look good, but I have to say I'm fairly pessimistic about the chances of this working. Well, here goes nothing. Nothing indeed. So let's check the voltage on pin 21 now. It's exactly the same. So maybe the service manual was wrong. I was just looking at this group of transistors near the chip, and I've removed Q403, which is a power transistor, and in the tester it's showing as a diode. So this could be it. It's a D1380. So I'm now going to test the others just in case. This is Q404. That one's okay. This is Q407. That's okay as well. And finally Q408. Also good. Well, this is great. This is the first significant problem I found with the board. I just wish I'd found it before I ordered that new chip. But anyway, I'm going to order a replacement for this, and we'll resume when it arrives. The new transistor has arrived in this ludicrously large bag, but before I fit it, I'm just going to check that it's working okay. That looks good. Let's get it in the machine. It goes in with the label facing this way. Well, after 2 lengthy delays waiting for parts, it feels like I've been working on this machine forever. But will it finally spin up a disc? Don't believe it. I think that new transistor's popped. So it may have been a symptom rather than the cause. Yeah, you can see on the thermal camera that transistor is over 100 degrees C, so I'm going to power that off. Ugh, I wish I'd got more of them. And I should have checked the pads before I fitted it to make sure there were no shorts. Well, incredibly, I've just removed the new transistor and it's still good. So I definitely got away with one there, but we must have a short. I'm going to interrupt myself here because what I tried next was ultimately fruitless. I wondered whether the transistors were testing okay in the low voltage multi-tester, but breaking down under increased load. So I made this little circuit on the breadboard to test them with voltage from my bench power supply, but couldn't find any problems. Well, having removed the overheating transistor, if I measure the voltage on the base pad, which is this bottom one here, it's nearly 11 volts, and that's much higher than it should be for a base. The base is essentially the switch that turns the transistor on and off, and it only needs a low voltage, typically less than 1 volt, to operate. So I just need to find out where that high voltage is coming from. Well, I may have found the problem. That 11 volts that's going to the base of this transistor is coming from this IC here, which is an op-amp. And there's actually 4 of them here, and they're all the same. And because there are 4 of them, I've got comparison points. The final pin is the voltage in, which is about 12.5. But the next pin along, on the suspected bad one, it's 11 volts. But on this one, it's basically nothing. Same with this one, same with this one. So I think we've got a bad op-amp. I think that's the problem. This op-amp here provides voltage to the spindle motor, and it's stuck in the high position. Now, do you remember this strange little board here? I think I said it was a phase shifter. Well, that has an identical op-amp on it, and I'm guessing this isn't critical for the operation. So I'm thinking if I remove the op-amp from here and use it to replace the suspected faulty one, that could give us an answer. Okay, I've swapped those op-amps. Let's try it again. This player is going to kill me. Still getting hot, but we don't have the high voltage anymore on this pin. So that was nearly 11 volts before, and now it's under 2. Well, I just tried disconnecting the transport and measuring again, and when I do that, the transistor no longer gets hot and the voltage readings are normal. So it seems that the problem is on the transport itself, or rather its PCB underneath. There are 3 connectors for the transport. This one is purely for the motors, this one's just for the limit switches, but it's this one that's causing that transistor to overheat. It goes to these pins here, but none of these pins are shorted. So I ended up delving deeper and testing the coils on the pickup, also the laser diode itself and the photodetector array, and that's where I found problems. Because essentially the photodetector is just a load of diodes, so they should only pass current in one direction, and on the multimeter they were passing in both directions. All of those pickup operations feed into this chip here. This is a TA7731P, and when I removed that, the photodetector readings were all normal again. So after a long search, and probably longer than it needed to be, I think this is the problem. I put everything back together with this chip removed, turned the unit on, and the transistor was no longer overheating. So I've ordered a replacement from the same guy, in fact, that I ordered the Yamaha chip from. But yet again, I need to wait for the replacement chip to arrive to see if I really have found the fault. The new chips have arrived. I had to get 2. They look like a good match. I still wouldn't say I'm feeling optimistic though. Okay, we're all back together, and the first thing to check is whether this transistor is behaving normally now. So let's power it up. It's getting hot again. Yeah. Well, I've spent about 3 weeks on this now with all the delays waiting for parts, and if I don't call it a day, there's not going to be a video this week. I've just removed that transistor again, and we're still getting 10.8 volts on the base. Well, I thought I'd try fitting the other new chip, since they sent me 2, and after doing that, this transistor is no longer getting hot. I checked the voltage readings and they now appear to be normal, but it still doesn't work. It's just absolutely cursed. Despite saying that I was going to call it a day, I spent further unsuccessful hours trying to find the fault. I really thought I'd cracked it on day 1 when I saw that the disc turntable was stuck, and it's hard to believe all the problems since. The Yamaha chip may have been a red herring, but the burnt out transistor certainly wasn't. And then what were the chances of the first replacement TA chip being bad as well? To find all these faults and still be no further forward is frustrating to say the least, but since everything is now reading normally on the board, I don't have anywhere else to turn. Do let me know if you think I've missed anything, but that's all for now. Thanks for watching, and I'll see you in the next one.